Well, here we've got a reaction to balance. It's a pretty messy one. We got hydrogens, oxygens, and quite a few reactants. And this is an oxidation reduction reaction. I mean, and these are pretty complicated. I mean, if you were trying to guess the numbers here, you'd be a better chemistry person than I could be. But the thing is that you don't have to guess them, because since it's an oxidation reduction reaction, it's governed by electrons being gained and lost, and they can be found pretty easily. And the first key is to come up with the oxidation numbers, which are sort of tell you how many electrons are sort of controlled or not controlled in things. Let's start with it right now. Let's get the oxidation numbers here. I hope you've already looked over the rules, so this will make some sense to you. But here we see we've got chromium, Cr. It's got a +3 charge. This is an easy one because it's a single element. Oh, I should say an ion. And the oxidation number of any ion, that's all by itself, is its charge. There we go, +3. It doesn't get much easier than that unless you have an element, which is always 0. So here we go with a +3. Now, if you've got a reactant, in this case we've got the chromium, you should go and see what happens to it as a product. Did it change any? Here we've got chromium in the dichromate polyatomic ion. And the dichromate polyatomic ion is a pretty notorious one, especially in oxidation reduction reaction, so this is certainly a suspect. So let's see. The entire ion, polyatomic ion, has a charge of -2. So we know this whole thing is going to have to add up to a -2. And that's our goal. Now, if this were a compound, it'd add up to 0. But this is an ion, so everything's got to add up to a -2. So let's see. Chromium, you really don't know much. Chromium is it's a transition metal. It's a chameleon. It'll keep on changing, not colors, but oxidation numbers. So we're going to have to find out what it is in this compound. Oxygen is pretty stable, unless it's an element or a peroxide, which you're warned about. It's going to have a -2 as its oxidation number. So I'm going to put down -2 because this isn't a peroxide or an element. Now we have a total of 7 of these oxygens, each with a -2. I'm pretty good at multiplying that. I wouldn't even get my calculator out. That's -14. So the oxygens have got this -14 to control with. The chromium is going to end up having to have an oxidation number, or total oxidation control, of a +12. Both of these chromiums, because we've got to add up to a -2. So let me get that number there underneath the chromium, and I'll even end up getting my little stamp. Oh, let me pull out a stamp. The stamps on this thing are pretty interesting. Let me see. I've got to get symbols, and where's my little parentheses symbol? It's got to be here somewhere. Oh, here's a parentheses. I'll grab this and I'll pull it out and stretch it out and turn it around, and there we go. The -12, the +12 and the -14 have got to add up to a -2, and I'll stretch that out some here. This is going to look real nice. This is going to look pretty. There we go. +12, -14, -2. We've got 2 chromiums, and so each one, we traditionally put the individual oxidation number above the element, is going to be a +6. So the chromium's undergone quite a change. It's gone from a single chromium's gone from a +3 to a +6. Remember, it's always good to have the single oxidation number up there so you can see if there's a charge. Now, hydrogens rarely, unless you've got the element, they don't really change much. If you had hydrogen gas, definitely it would undergo oxidation reduction. But hydrogen's a +1 almost always. And here's oxygen in a compound, -2, doesn't change any. Now here's chlorine. Now again, chlorine is a notorious substance too, so let's deal with the chlorine right now. We've got our standby, which is the oxygen. I'll get that as a -2. There are 3 of them. So let me just move that. So the -2, in fact, right now what I'm going to do is I'm going to go and copy this and put that right now over the other oxygen in this compound. Paste. There we go. There's my -2. Again, oxygens, unless it's an element or a peroxide, is going to be -2 in a compound, naturally. Okay. Now, let's see. We've got six of these -2s, and that's going to be a total of -6. Right there. Nice, easy multiplication. Let me move it around. And this is the ion 2. That little negative there means we've got a -1 to worry about. So I'm going to copy my little parentheses. It came in handy. And put it underneath here, because everything is going to have to add up to a, here we go, -1. And that means my chlorine, my single chlorine, has to have a +5. +5. And there we go. That looks pretty. And there's only one chlorine, so you know the chlorine has a +5. That's a that thing is going to gain electrons. I mean, if you've got a +5 charge, that indicates that you're going to be really, really attracting electrons. This is going to be something that's going to gain electrons. It's going to reduce. It's going to be an oxidizing agent. Oh, remember AP, we don't have to worry about agents. Okay, so here we've got chlorine with a +5. Let's see what chlorine is as a product. Now the Cl2 is a compound, so this is going to add up to 0. Let me see. 2 -2 oxygens is going to be a -4. Right underneath this O2. Underneath, I traditionally end up putting, this is the total. And then the chlorine goes to a +4 because this is an element. I mean, I'm a neutral compound, so it's going to add up to 0. And hey, did I predict it? Yep, the chlorine's picking up an electron and turning down from +5 to +4. Very often it goes even more than that. But still, it grabbed an electron and ended up reducing its number. It's a quick way of remembering things. So the chlorine reduced. And of course, the chromium here is oxidizing. Whenever you've got something that's oxidizing, something else has to be reducing. You can't have loss of electrons without a gain of electrons, unless you're a lightning bolt. And even then, the lightning bolt loses its electrons. So that's it. No gain. So it's going to end up being a net 0 gain. So we have our two substances. That's all we need for an oxidation reduction. Chromium, which is, loses electrons, loss of electrons. Leo is oxidation. And we got chlorine picking electrons up, but they're not the same. In fact, here, let me show the reaction. Here's 1/2 reaction, because, there's 2 halves to oxidation reduction. 2 halves. +3 to +6, it's losing 3 electrons. Those electrons have been kicked off of it. Chlorine gaining 1 electron, but as I said, we have to have equality when we have oxidation and reduction. So I'm going to get my red pen. Here I'm picking it up, and I'm going to say, this reduction reaction's got to be multiplied by 3. We're going to need 3 chlorines at a +5, picking up each one of these electrons that the chromium ends up providing us. So we know that there has to be 3 times more chlorine than there is chromium. That's the heart of balancing the reaction. Once you figure that out, the rest is going to be easy. You've done all the hard work. It's finding out electrons lost versus electrons gained. And here I'll use my parentheses again. That was a sloppy one, but I can just multiply that by 1. So 1 chromine, 3 chlorines. You absolutely have to have that. Otherwise, you've got orphaned electrons. So let's look at our reaction down here. Here's our 1 chromium. Look, there's a subscript 2 here. So that means that we're going to have, without doubt, 2 chromiums here in this balanced reaction. In fact, let me even get that to a boldface and increase its number there so we can see it. Now, we're forced to have this 2 in front of the chromium because here it is as a dichromate. Nice name, dichromate. A di for the 2 chromiums and the 8 indicating that it's got a heck of a lot of oxygens. Now, the next thing we can go to is the chlorines. Now, we said there are going to be 3 times more chlorines than chromiums. Well, we got 2 chromiums, so hey, 6 in front of our little chlorous ion or chloride ion. And then if we have 6 chlorines here, 6 chlorines here. Now, we also know that this chromium here is going to have a 1 in front of it. Now, you wouldn't really put that number down, 1 there, but I'm just doing it here so that we have established things. Now, we use 2 things. We use the substance that, in this case, went from +3 to +6. It oxidized, lost electrons, 6 electrons. And here we've got our thing that reduced, where we've got our chlorine. And now we pretty much have this taken care of. This is it. It's going to have to run this way. Now, in a college thing, you'd be expected to worry about the acid and the base, but for AP, that's it. But let's check if we landed this correctly. Let's see if we landed this plane by looking at the oxygens, because that's our final check here. Now, there's quite a few. We've got 1 oxygen here, and we've got 6 times 3, 18. So my oxygens are O equals 19. Now, do we have 19 oxygen in our product? If we don't, we're worried. Well, let's see. Let's see if this is working out. Well, we got 7 oxygens here in the chromate. And then we have 6 times 2 is 12. Oh, 7 plus 12? Hey, our oxygens in our product, oxygen equals 19. Man, we've got this taken care of. 2 hydrogens, everything else is perfect. Oh, hey, you've mastered, we've just done a pretty complicated oxidation reduction problem. Okay, let's hear the applause. There we go. Okay, that's it.